Hi, welcome back to Unit 2 for AP Physics C. This is going to be the last topic in this unit. This is going to be on circular motion. Again, AP Physics 1, a lot of the concepts don't change between the two. The problem solving is the same. We just may add in a little bit more calculus to the problem. So remember, centripetal acceleration is an acceleration directed inward or towards the center of the path. The magnitude of the acceleration is going to be given by the equation a sub c equals v squared over r. V is the linear speed, okay, and that's going to be tangent to the circle that is created. Centripetal acceleration can result from a single force, more than one force, or components of the force. In fact, this probably should say centripetal force, not acceleration. Okay, so something to remember is that centripetal force is not a force drawn on a free body diagram. It is a result of those forces drawn on a free body diagram. So if you look at like up here in the top right with the race cars, it's going to be friction that's going to be keeping them on the track, right? And so the centripetal acceleration is going to be inward, even though now it is on a bank turn. In physics 1, it would have been more like the picture below it, where it's on a flat surface. Here in physics C, we're going to be doing a little bit more with the bank turns, right? So if we're drawing our free body diagram for our car, you have the normal force there, you would have weight, and then you have friction kind of hanging out here, okay? So Fn, sorry, I'm writing blue on blue basically, and Fg, okay? And now when we do problem solving, before we did like a t-chart with x and y, now our t-chart is going to really consist of circular and non-circular motion. Typically, the sum of the forces in the non-circular direction will equal 0, and the sum of the forces in the circular direction will be mv squared over r, right? So mass times acceleration. Now, the tangential acceleration, here's again a difference between physics 1 and physics C. In physics C, you could have an acceleration where the car or the object is speeding up or slowing down as it's being pulled into a circle. And so the resulting acceleration ends up being, kind of a Pythagorean theorem situation. So a sub c squared is going to be, so a, the overall acceleration, is going to be the square root of ac squared plus at squared, okay? So the net acceleration of an object moving in a circle is the vector sum, okay? Now, the revolution of an object traveling in a circular path at constant speed can be described using period and frequency. That's our v equals 2 pi over t, or 2 pi rf, because remember, t and f have a relationship of 1 over f, right? Period is 1 over f. The 2 pi r, it comes about, right, because we're going to be traveling in a circle, and the distance you travel in a circle is, in one complete circle is the is the circumference of said circle, okay? So let's look at an example problem using this. So here we have a billiard ball attached to a light string of 0.5 meters, swung so it travels in a horizontal circular path as shown. So this is what they call a conical pendulum. So on the diagram, draw a free body diagram of the forces acting on the billiard ball. So let's do that real quick. So on our diagram, you would have the weight of the billiard ball down, you would have the tension going up and to the right, and those are the only forces acting, okay? So, and to understand the acceleration, all right, or the centripetal acceleration is going to be just inward along that circle, okay? And so part B says to calculate the force of tension in the string as the ball swings in a horizontal circle. So that is going to be our centripetal or our circular side. So again, non-circle, circle, right? That's what we're looking at. And what you need to do is really do something on the non-circular side so that you can figure out the circular side, okay? Because the way you look at it, and so you can figure out this angle or you can figure the angle down there. Now, don't be scared because they don't give you the angle, but they give you enough information, right? They give you that the string is 0.5 meters long and the path of the circle is 0.4 meters, right? So essentially you have a right triangle, 0.5, 0.4. And so you can do like your sine and cosine. Well, the other side is going to be 0.3 because this is just a 3, 4, 5 triangle. Okay, so if I want T non-circular, okay, that's going to be my vertical, in our picture. If depending on what angle I want to use, I can do sine or cosine. Okay, so this if I want to, I know I'm keep drawing on the diagram here. So this is the T non-circular component. So that would be our sine. So we say T sine theta. Okay, where sine theta is simply 0.3 over 0.5. Oh, not sine theta, but T. This would be times T. Or, right, T non-circular is going to be 0.6 T. Okay, so I'm going to have T non-circular minus FG equals 0. So T non-circular is going to equal FG. So 0.6 T is going to equal M times G. And just kind of working my way down, right? So we're going to have T equals mg over 0.6. They tell us it's 0.150. We'll multiply that by 10 times 0.16. Sorry, I don't have my notes for this to just simply tell you what the answer is, but I got to do a quick calculation. All right, so the tension in the string is going to be 2.5 newtons. So that is our answer to part A. Now part B, we got to go over to the circular side, okay? So it wants us to determine the magnitude of the centripetal acceleration. So here we're going to say T circular, and note that is the only force that is acting, okay, equals MAC. So T cosine theta is going to equal MAC. Well, we found that T is 2.5. Cosine is 0.4 divided by 0.5, and that's going to equal 0.150 times AC. So I can do so this is 2.5 times 0.8. Again, you can do the algebra before you start substituting in numbers, typically what I do, but I kind of moved forward before I did the algebra. So the centripetal acceleration, again, I don't have the calculation completely done. So it'll be 2.5 times 0.8 divided by 0.150. And so that tells us that the centripetal acceleration is going to be 13.3 meters per second squared. All right, part D says calculate the period or time for one revolution of the ball's motion. Well, we know the equation is going to be 2 pi r over t, but we don't know what v is. But v, we can find from a sub c equals v squared over r. So r, not r, we want v. So v will be the square root of RAC. So we're going to do square root of r. So the circle is 0.4 meters in radius times 13.3. That was our centripetal acceleration. Again, I apologize for not having my work done. So 5.32, take square root of it, and we get a v of 0.230 meters per second. Now that goes up here, and so I manipulate this equation. So t is going to be 2 pi r over v. So 2 pi times 0.4 over 2.30. So 2 times 3.14 times 0.4 divided by 2.30. And we're going to get a period of 1.1 seconds. All right, so this actually ends Unit 2. So we'll dive into Unit 3, which is going to be the work energy power unit for AP Physics C mechanics.